Thanks, Doctors Azaguri and Blevins, and everyone for being here for this course. I think it's really exciting to have this type of content at Sages. So I'm really hoping this will be a first of many years that we continue to do this. These are my disclosures. And start with a quote. So all truth passes through 3 stages, and you could just switch out the word truth for innovation. First, it is ridiculed. Second, it is violently opposed. Third, it is accepted as being self-evident. And so this stepwise progression from resistance to acceptance is a theme that has actually been present in the past 500 years of surgical innovation. So Vesalius, he was an anatomist and a surgeon. You may be familiar with the book he published. It was called De Corpora Humani Fabrica in 1543. And this book actually refuted ideas about human anatomy proposed by Galen in AD 150. So for 1,300 years, doctors, surgeons were operating with mistaken understanding of human anatomy, which finally he was able to refute. And when you look at everyone's faces who does this innovation, I think these pictures tell us everything. Joseph Lister, he associated germs with wound infections and really started to try and tell surgeons, hey, normally the surgeon would wear the same smock in the OR over and over as kind of like a battle, like, this is my dirty, bloody smock. I wear it for all my cases, and it shows what a great surgeon I am. He started to encourage people to hey, change your clothes, wear some clean clothes. Also, wash your hands, maybe. And he, went to the World Fair in the U.S. in 1867 and was heckled on the podium, but nevertheless, continued with his steadfast belief in, sterile surgery and finally changed the culture. Kurt Sem is a German gynecologist who is responsible for much of what we do today. He invented the electronic insufflator, the Bovie, the endoloop, extracorporeal knot tying. Co-workers recommended he get a brain scan, as only a person with brain damage would do laparoscopic surgery. He did the first ovarian, laparoscopic, can't even think of the word, ovarian removal surgery. And he did the first laparoscopic appendectomy, at which point his paper to the OB-GYN Society was rejected because the technique was considered unethical. Many people recommended he have his medical license removed for doing this innovation. He did get a Sages Innovator Award, I think, in 2002. Irving Lichtenstein developed the mesh-free hernia repair, which we all, or many of us, do today. And again, at conferences, he would be disparaged, and everyone says, you're crazy, don't listen to him. Yet this is our standard of care. Final innovator is George Bersey. He is now turning 103 this year. I was fortunate enough to meet him at the first Sages I ever attended in 2013 in Baltimore. That's him over there. And he developed modern laparoscopy. He introduced the inventor of the rod lens system to Storz, Karl Storz, and developed, us operating on screens. And I don't think he had any hardships. I don't know, because he was so awesome. This is mandatory reading for everyone at Sages. So really briefly, just the stages of innovation. I know you talked about this morning, but there's usually an idea phase, a regulatory phase, a commercialization phase. So for, me, this is just a brief summary of the idea phase of Endolumix, the device I've been working on. I'd say all paths go back to Duke, like Dr. Pryor says. So really it was as a fellow at Duke in 2015, in the OR, there there's, multiple industry representatives. They want your opinion, they want your input. You can go to labs and work on new devices. I remember going to the Teleflex lab and working on their percutaneous instruments. And that really piqued my interest is, you can do this as part of surgery, working on devices, technologies. And I think that's where my interest in innovation started. And then as I moved to West Virginia, University of West Virginia, or West Virginia University, I noticed in the OR and bariatric surgery, persistent challenges with our team for simple things in the OR, like placing an OG tube to decompress the stomach, placing a bougie for bariatric operations. Often we would have different providers every day. And these seemingly simple things became tedious because sometimes the stomach isn't decompressed. You have to take out the tube, put in another one, and just wasting time. I also observed on a national level adverse events relating to bougies. So perforations, people stapling across them because of the automated staple technology can cut through almost anything, and there's very little feedback. Looking into it further, you see that calibration tube related complications are costly. They can, lead to over, 500 million in costs a year. And so I thought, is there a way to make a better calibration tube? I actually approached industry, one of the main players in the industry at the time, and I said, hey, you have a good product, but it would work better if you if you made it a lighted bougie and a fluorescent guided bougie. We started the early talks of a consulting agreement. They sent me a contract that was pretty, severe, basically, with wording like anything you come up with while you're consulting for us, we own 100%. I redlined that contract, sent it back to them, and never heard from them again. And so I thought, let me try and make this myself. And so this is kind of the device we came up with, which is a fluorescent guided calibration tube. It has suction ability, leak testing ability, and also this idea of measuring. So you can see here that based on the lights and the markings on the tube, we can now start measuring intraoperative lengths. And it's all based on this principle of fluorescent guided surgery. So this idea that white light does not transmit well through biologic tissue, some of that is just the wavelengths of white light, and hemoglobin wavelengths absorbs white light. So in the top left picture, there's an actual endoscope with its light on right there. That's our GE junction, but you can't see it due to the thickness of body tissues. However, near-infrared light penetrates more deeply through tissues, about 1 centimeter. Some people say 1 to 2. And you can see near-infrared light readily. What's great about most of the modern camera systems is they now have an overlay mode where you can work in white light and near-infrared light together. This creates, in my mind, a form of augmented reality where the white light shows you the things on the outside, the near-infrared light shows you kind of something on the inside. And so this is where, I felt like there had been lighted bougies in the past, the Medtronic Gastrocell, Diversitech Intervision, but there had never been a near-infrared product. So fast forward, just some prototyping. Those things, you get those little mini Christmas trees with this thing on it. It's like little lights. I was like, let me start with this. I got a sock. I took a shoebox into the OR and used the lap camera in the OR, in my little shoebox to make sure this worked. It did. So we continued with some grant funding. Many institutions have these innovation grants. So I applied for a $50,000 innovation grant to kind of do more proof of concept testing. This was our 3D printed prototype, and got some pig stomachs just to kind of, again, test this concept. Can we use this as a fluorescent guided tube to see both inside and outside and make measurements? The most important person for this process was actually my Stryker rep, because at the time WVU had the Stryker 1588 system, which is slightly draconian. And I had to have him bring in a 1688 educational tower, and he really enabled this up to this stage. And let's see. And I think that kind of brings up my next point, that for innovation, teamwork, like Rory touched upon, is truly essential. You meet a lot of people who say, I would like to do this all myself. That means you are a clinically practicing surgeon. You probably have a family. And you also want to run a company, meaning the science and the business. And I don't think that's great. Really, the most important person, if you're an innovator who you want to start looking for, is a business partner or your CEO. And the first job of a CEO is what one of my mentors told me, is to make it rain, as in rain money. That is the only job of the CEO to start with. So I met Mara, who is my CEO. She has a background in engineering, got an MBA, and wanted to become a serial entrepreneur, was working in the innovation space in Pittsburgh. And we had a deal. We said, hey, if you can raise enough money to get us through regulatory, about $500,000 to $600,000, can give you some equity in the company, and we'll move forward. And she did that. She raised that amount of money, $675K, and that enabled us to get through regulatory with a very tight budget. It did not hurt to win the Sages Shark Tank in 21. But we continued to just validate our product and get ready for the FDA. It was a 510K submission. The predicate device was both the Medtronic Gastrosale and something called the Visigi, if you know what that is. We also had secured patents, and I'll touch on what Rory brought up, is if you're not happy with your original patent, what my experience has been is WVU paid for our initial patent. However, once we had our seed round raised, we hired our own legal team. They looked over the patents that were still waiting in the queue of the USPTO, and they said, let's expedite. They thought the measuring was very novel. Let's expedite the measuring element as its own patent, get that granted, and then we can wait on the rest. And they're a very skilled legal counsel. They did that, and we were able to get an expedited patent around the measuring applications. We're still hopefully waiting to hear about the rest. I think Dr. Azaguri has so much helpful knowledge about patenting that it's not the idea, it's how you embody it. And I think you got to listen to him on that. So again, we got through the FDA. We submitted in September. Were approved in March of 2023. We also applied for this FDA STEP program, which is a safer technology program. We didn't realize at the time that we're actually the first device to ever have gone through and been granted STEP certification, which basically means the FDA looked at our technology and believes, based on the data we submitted, which was just really basic ex vivo and cadaver studies, that our technology is safer than the current bougies in practice. This was our manufactured device. Here's a video. This is our clinical trial from back in August. And you can just see, this is on the Stryker 1688 system. So for a sleeve, introducing the device. I've used this product now for 6 months. I disclose to my patients with a separate form about my conflict of interest. I explained to them that I created this to improve what I can see during their surgery. I explained to them that the FDA actually thinks that this is safer than the current standard of care, and I give them the choice or ask permission to use it. If they're not comfortable, of course, I would never use it. I think it's critical to be transparent. This, demonstrates early applications of a sleeve and just a primary straightforward sleeve. We have some application in the bypass. We're moving to more applications in revisional and foregut surgery. I think, one thing a lot of people say is, I've done 3,000 sleeves in my life. I don't need anything more. And while I can't argue with that, I think sometimes surgeons who are extremely experienced, as in 10 plus years, forget what the experience is for new trainees and people right out of practice. So I think, this technology improves what you can see in the OR, and the older people may think they don't need to use it, but when we're seeing a 300% in revisions in the past decade, we are also operating in more complex surgical fields, and I think anything that can provide more visual cues, similar to ICG, is a positive thing. So this is, our FDA-approved product. I think, there's things it does really well. Number one, improve your communication with your anesthesia provider. Everyone is looking at the same thing. Absolutely decreasing the risk of perforations and stapling the tube. Improving placement of staple fires. We still have not solved as a surgical community this GERD post-sleeve. We know anywhere between 10 and 20% of people experience GERD after a sleeve. We haven't standardized the sleeve, so it's very difficult to really tease out who are those people getting GERD and why. Is it based on the shape of the sleeve? Is it something else? What I love about the device is this last staple fire at the GE junction. It gives you a little more information about exactly where the esophagus is coming through. You can avoid being too close to the GE junction, cutting the muscle fibers, versus having a dog ear. I'm hoping to partner with someone involved in computer vision and AI to really hone in on GERD post-sleeve, because with the tube, we can now compare variability between surgeons and outcomes. Finally, working on measuring. Again, this is a very novel concept, but the idea that near-infrared light can help with measuring in the body. So many people, when they do a Heller myotomy, they still bring in a little piece of ruler and they put it through the port and they measure to make sure their Heller's adequate length. That you can now see measurements without putting things in and taking things out of the surgical field. So yeah, and we're in the commercialization phase, and I'll say the idea phase is something very easy to understand. The regulatory phase is very mathematical and algorithmic, so it's also something that you can learn. The commercialization phase is definitely the real world. So, in the past, really since last June, we've had an employee try and steal from the company by telling the hospital, billing the hospital one price and telling us another price, and trying to pocket the difference. So there's a lot of stuff in commercialization that I think as physicians, we're very honest people. And I don't think we necessarily think that way. And so there's a lot of real world stuff that you're just not ready for. And I think this is where the team component, I'll just double down. I think the best innovators are people who can work well with a team and identify their weaknesses and find team members who can complement with strengths. So my CEO, I personally am not really allowed to talk about price, contracts, business. My director of sales and CEO say, don't you dare. When your friends say, if it's the same amount as this other product, I'll use it. Otherwise, I won't. I'm not allowed to talk about that. I think that's fair. I think as the surgeon, you want to provide clinical support and kind of knowledge about the need, but then having other team members to do those other roles. So again, this is our director of sales. This is our marketing person. And then, as you build a team and you're going to start building an organization, it's going to be from this little project in your garage to an actual commercial entity out in the world. And that's where I think it's very important for you to really build something that you're proud of in terms of the values you represent. So, for us, we want to be a catalyst. I truly believe that fluorescence guidance can change how we are doing surgery, make safer surgeries, make us better surgeons. I will double down on that. Being accountable, I think this will make our operations safer for patients. Zealous, you got to believe in what you're doing. And inclusive, right? So I want to create a community. Currently, women in technology represent about 2% or less of, the really movers and the shakers, less than 2% female CEOs. So again, for our company, we want to have a very inclusive company and also partner with companies who have those values. This is our distribution network. We partnered with regional distributors. And this is a list of everyone using the device since last June. And just wait, goes on to 2 pages. So I was surprised to see this yesterday because I haven't been keeping up with all this stuff. But that's my experience, and thanks for the opportunity to present.